This problem says angle FGJ, which is this angle right here, is congruent to JGK, which is this angle. And it also says that angle JGK, same angle, is congruent to angle KGH. And then it gives the measure of FGH and the measure of KGH, and it says find or prove that x is equal to 6. When you're working a proof, before you start down, or before you start proving, before you start doing anything, try to make a plan. Try to have a plan of action. How am I going to go about this? Well, let's talk. We have two angles that are congruent. Angle 1 here and angle 2, but angle 2 is also congruent to angle 3. So what does that mean about those three angles, or any ideas? They're all congruent. If one angle is congruent to a second angle, and a second angle is congruent to a third angle, then the first two, or the first and last angle must also be congruent. Haven't we talked about a property that states that? Yeah. And we're going to use that property a lot. And that's the reason I think I had you start in your notes. I believe that would be the transitive property. One thing is congruent to a second thing. A second thing is congruent to a third thing. That means the first and the third are also congruent. That's what you have here. All three of these angles are congruent. Now, let me share something with you that kind of throws people for loops. It talks about angles being congruent. Angle being congruent. It says nothing about angles being equal to each other. Okay? There's a big difference between equal and congruent. Well, not a big difference. Angle measures are equal. Line segment measures are equal, the length of them. The actual line segment is congruent. The actual two angles are congruent. Okay? Shapes are congruent. Measurements are equal. And go back and let me show you something. All these properties that I gave you yesterday, the addition property of equality, is that a congruent sign? No, it isn't. Do you see any congruent signs anywhere on this page? No. So when you're performing proofs, for now, when you're going through and you're trying to prove something, when it says that two things are congruent, you can't use the addition property of equality. You can't use the subtraction property of equality. You can't use the transitive property of equality because it says absolutely nothing about equality. And this is extremely picky when we go through these, and I know that it's going to seem picky, but just for now, just go with the flow. If you want to use the transitive property of equality, you're going to have to do something with that. But first off, let's go through and do this. We're given that, and I'm not going to do this on every problem, but we're given that angle FGJ is congruent to angle JGK. We're given that angle JGK is congruent to angle KGH. We're given that the measure of angle FGJ equals 6x plus 7, and we're given that the measure of angle KGH is equal to 8x minus 5. Why? Good. Your first step is always listing what is given. And honestly, this will be the last problem I do that. I'm going to probably just leave this blank, come over here, put a 1 for given, and put a ditto or something just to save a little bit of time from here on out. Okay, but that first step is always list the things that you are given. Step number 2. And this is what I was kind of getting at just now. I know that if FGJ and JGK is the same, and JGK and KGH are the same, then that must mean that FGJ and KGH are also the same by the transitive property. But I can only use the transitive property if I have equal things. So what I'm going to do in step 2, and this is going to be normal. You're going to do this on most problems. If FGJ is congruent to JGK, that means that the measure of angle FGJ is equal to the measure of angle JGK. And that also means that the measure, since they're congruent here as well, the measure of angle JGK is equal to the measure of angle KGH. Because that's the definition of being congruent. That's what it means to be congruent. If two things are congruent, they are equal in measure. And the whole reason I did that step 2 is because now I can use that transfer property. Now if I wanted to, I can use addition, I can use subtraction, I can use multiply. I can use all those properties of equality. Here, I can't use properties of equality because it's discussing congruence, not equality. And I'll go through this and then we'll ask questions after it's over and then do a couple of them and then let you try some yourself. If JGJ is congruent to JGK, or FGJ is congruent to JGK, JGK is also congruent to KGH, that means that these two must also be congruent. So my next step is that the measure of angle FGJ will equal the measure of angle KGH. That is the transitive property of equality. Okay, let's bring you up to speed with what we've just done. We pretty much stated that these two angles are now the same. FGJ and HGK or KGH, however they put it, are the same angles. And I used the transitive property to prove that. These two angles are the same. Have we done this type problem before this year? Yes. Okay. Have we done it in a proved form? No, but you've thought your way through it. If these two angles are the same, and again, look what we're trying to prove. We're pretty much trying to find out what is x. Since we now know that these two angles are the same, up here it says that FGJ is 6x plus 7. KGH is 8x minus 5. So somebody tell me why I can do this. Let's scroll down. Step 4, 6x plus 7 is equal to 8x minus 5. Does anybody know why I can do that? What did I just do? Because they're equal to that, right? FGJ is 6x plus 7. That's it right here. KGH is 8x minus 5. It's right there. So what property says that? Somebody's about to say it. Substitution. The substitution property of equality says that when two things are equal, I can take one of them out and I can substitute another one in. The same thing as substituting players in on a basketball court. Take one out, put another one in. You don't want to put a 5 in for a 1, right? You don't want to put a 2 in for a 4. You put 4s in for 4s, you put 5s in for 5. So now what do? We're trying to prove that x is equal to whatever it was equal to. We're trying to prove that x equals 6. So now all of a sudden, this has just turned into a problem like you did last night for homework. So from here on out, you're solving this equation. Step number 5, I'm going to say that 7 is equal to 2x minus 5. The way that I did that was I subtracted 6x, and I believe that would be the subtraction property of equality. Step number 6, let's move the 5 over here. That would be 12 is equal to 2x. And I would believe that would be the addition property of equality. And finally, last step, step number 7, well, no, I lied to you. This is not the last step. To get rid of 2, I'm going to divide both sides by 2, and I have 6 is equal to x, which is your division property of equality. And finally, step number 8, x equals 6, which is the one that tends to be confused If 6 equals x, why can I write that as x equals 6? What property was that? Symmetric. Property of quality. Reflexive, okay, you and the mirror is the same, right? Reflexive is 2 equals 2. Symmetric is if 6 equals x, then x equals 6. You can flip-flop those around. So we have proven what we tried to prove. We're trying to prove that x equals 6. We now have that x does definitely equal 6, and we listed the reasons why we did each step. Next problem. And some of these things are going to seem common sense, and they're going to seem like, well, yeah, that's easy to see, but it's not always easy to prove. We're given that, well, I guess we can go ahead and write it down as I'm saying it. Make you a little T-chart here. Statements, reasons, and I am going to list these. We're given a CE is congruent to Fe, iron, and we're given that ED is congruent to EG. Given. Never miss that. So we're given that this line segment is congruent to this line segment. And we're also given this medium-sized line segment is congruent to this medium-sized line segment. And we want to prove that CD, this whole thing, is congruent to FG, that whole thing. Now, how in the world are we going to do that? Just watch through the first few. Again, before we can use our properties of equality, we've got to do something with this congruence symbol. Because we have, as of right now, we have no properties of congruence. We have properties of equality. So the first thing you'll need to do is if they're congruent, then they are equal. Anytime the bar is not above it, you're talking about the length. So CE is equal to FE. The length of CE is equal to the length of FE. The length of ED is equal to the length of EG. By the definition of congruent. Again, that's what it means to be congruent. If two things are congruent, they're equal in size. They're equal in length. That's going to be your first step for most of these problems. Step number 3. See if anybody can tell me why I can do this. Okay. CE, let's try that again. CE is equal to FE. So what about CE plus ED? Would be equal to FE plus EG. What in the world did I do there? CE plus ED is equal to FE plus EG. Why can I say that? Does everybody understand? Okay, first off, CE, we're given right here that CE, I don't want to write this morning. CE and FE are the same thing. I added to the left side ED, I added to the right side EG. ED and EG are also the same thing. The addition property of equality states this. If two things are equal, 3 equals 3. You can take and add anything to both sides of the equation as long as you're adding equal things to both sides of that equation. If you took the equation 3 equals 3 and you added 4 to one side, that's legal as long as you add 4 to the other side. That's the addition property of equality. If you added 7 to one side, add 7 to the other side, it's still equal. So if you have equal things and you add equal things to both sides of that equation, they're still equal. So CE equals FE I added ED and EG to each side. That is the addition property of equality. And now let's revisit some chapter 1 stuff. Here's the thing about geometry, guys. We can never forget anything. If we covered a theorem, if we covered a postulate in previous chapters, remember it. Write it down. Start it. Go back, look in your notes. Review it. Before chapter 3 test, you might want to review some of your chapter 1 and chapter 2 stuff. But see if you can figure out where this comes from. Let's scroll back up so I can see that picture. CE plus ED is equal to CD. And FE plus EG equals FG. And I want you to sit and look at that for a second. Don't answer. Don't give me the reason yet, because I want everybody to look at it. Everybody try to figure out, why is this true? Does anybody know why that's true? See if this jogs your memory. If this is 3, the whole thing is 7, this is 4. Y'all remember doing that? The whole is equal to the sum of the parts. If you got 3 and 4, the whole thing would be 7. Is that not what you're doing here? CE, if you put CE and ED together, you're going to get CD. What was that property, or what was that postulate? It's actually a postulate. Segment, addition, postulate. So this, hopefully this is our first eye opener of the year. Every postulate, every theorem, later on we get into corollaries, every corollary, every definition, do not forget them. Do not throw them away. Linear pair postulates, don't forget it. Let's see what's more that we've done. Angle addition postulate, don't forget it. Definition of bisect, definition of a midpoint. Okay, don't forget those things, because what if now you have proofs that are going to need those things? And that's one of the hardest things about geometry is just, okay, now what did I do back in chapter 1? But it all builds on each other, and honestly, sometimes it's hard to forget. So look at our last 2 steps. In this step number 3, I said CE plus ED is equal to FE plus EG. Well, hang on a second. Look what CE plus ED is equal to. Look what FE plus EG is equal to. And you're trying to prove here that CD and FG are the same. They're congruent. You see what my next step is going to be? Go back to step number 3. CE plus ED is equal to FE plus EG. Well, CE plus ED is this. I'm substituting in CE plus ED. Take step 3, substitute in CD for those 2, and substitute in FG for those 2. I'm nearly done. So here again, I started with a plan. I should have been more vocal with my plan. My plan was, well, if these 2 things are the same, let's just say that they were 2 and 2. And also these 2 things are the same. Let's say that they're 4 and 4. Well, it's obvious that if I put this together with this, and I put this together with this, they're still going to be the same. And that's the steps I just went through. The way I did it was, well, put this together with this, and I get the whole thing. Put this together with this, and I get the whole thing as well. So therefore, the 2 pieces, when they add together, must equal the whole, so therefore the whole must be the same. So CD is equal to FG. That's not what we were asked to prove, and you've got to be specific here. We were not asked to prove that CD was equal to FG. We were asked to prove that CD line segment is congruent to FG, and we can now state that. 5 was, by the way, substitution. I plugged in. Substitution, property of equality. Step 6 is definition. If they're equal, that means they're congruent. So that's the definition of congruent. Here we're given JL is congruent to KM. JL, everybody sees JL there, is congruent to KM. This line segment is congruent to this line segment. And we're trying to prove that this little line segment JK is congruent to this little line segment LM. Plan? Tell me something you noticed. Any observations there? The what? The K and L, we just need to take that out, right? It's all about that KL in the middle. If you took JL and you took off KL, you take KM and take off KL, you see what you're left with? Those two being congruent. If you need to, throw some numbers in there. Let's say that JL is 10 and KM is 10. What if KL is 6? If you took that KL off of each of them, guess what? These small pieces are the same. So we've got to somehow subtract off that KL. We've got to take that KL off of both of these. So that's our plan. Okay, and you've always got to sit down and try to establish a plan before you start on this. Not given much. JL is congruent to KM. Given. But let's go back to that whole segment addition postulate. Because we've got to sum up, that segment addition postulate gives you a way of breaking this line segment down into pieces, if that makes sense. But before we do that, before you can use the segment addition postulate, before you can use any kind of subtraction property, addition property, go ahead and take this JL being congruent and write it as JL equals KM. And again, that would be because of the definition. That's what it means to be congruent. That's the definition of congruent. If they're congruent, then they're equal in measure. Let's break it into pieces. Step number 3. And I'll go ahead and tell you, by the segment addition postulate, we don't have much to work with. We haven't had a ton of postulates, theorems. So, by the segment addition postulate, somebody tell me what adds together to give me, well, let's start with JL. What pieces make up JL? J plus KL. Right? And let's take and do the same thing for KM. Let's break it down as well. What pieces make up KM? K plus is equal to KM. So let's see if you can tell where we're going with this. So now this JL and KM, we've kind of broken into little smaller pieces. And do y'all see that KL there? And we've said that KL is the common piece, that if we can somehow take it out of both of them, we can see that those other two smaller pieces will be the same. So we've got JL and KM being the same. Well, JL from here, JL is equal to this. So we're going to take this and plug it in there. We're going to break that JL into these two pieces. We're going to take KM, which is equal to this. We're going to plug that into there. And we're going to rewrite them in step 4. Instead of JL equals KM, we're going to write it as JK plus KL is equal to KM, which is KL plus LM. Why can I do that? I took this statement and I rewrote it as that statement by using statement 3. JL equals KM is the same thing as saying this equals this, because JL and KM is equal to those two things. So I took things out I put things in that were equal to them. That would be your substitution property of equality. You take things out, put things in that are the same. That's substitution property. I could nearly let you buy with transitive on that. This is equal to, if this is equal to this and this is equal to this, then the two must be. I could nearly see where that would be transitive, but let's use substitution. And that's kind of what you have here. We're going to take equal things off of both sides. Y'all see that you've got a KL here, you've got a KL here. And again, keep in mind what you're trying to prove. And keep in mind the plan that we have. We're trying to prove that JK is the same thing as LM. You see we can take that KL off both sides now? Think about the drawing. And that was the whole plan. Well, let's break it into pieces. Let's take KL off, and you're left with the smaller pieces being equal to each other then. You see how you can subtract this and kind of mark it out? We can now write JK is equal to LM if we subtract this off of both sides. Subtract KL from both sides by using the subtraction property of equality. But that's not what we're trying to prove. We have just proven that JK equals LM. The length of JK is equal to the length of LM. We're trying to prove that JK is congruent to LM. That's the same thing, right? JK is congruent to LM because if they're equal in length, then they are congruent. That's what it means to be congruent. That is definition of congruent. These are now our best friends. I kept saying a while ago that we have an addition property of equality. We have addition property, or excuse me, a subtraction property of equality, a transitive property of equality, a symmetric property of equality. Well, here's your three more properties. These are your properties of congruence, which should make sense. I mean, equality, congruence are pretty much the same thing. But instead of having to say, well, if they're congruent, then they're equal. And then we apply the properties, and then we say, okay, now if they're equal, then go back and say, well, then they're congruent. We can now have these three new ones. The reflexive property of congruence, the symmetric property of congruence, and the transitive property of congruence, not equality. The reflexive property of congruence says every shape is congruent to itself. Every shape. Not every measure, not 3 equals 3. That's not what we're saying anymore. Every shape is congruent to itself. Every triangle is congruent to itself. Every angle is congruent to itself. The symmetric property says if one triangle is congruent to a second triangle, then that second triangle is congruent to that first triangle. You can flip it around. Same thing the symmetric property of congruence says. Except for now you're dealing with shapes. And the third transitive property says if two shapes are the same and that second shape is congruent to a third shape, then the first and the third shapes are also congruent. Another proof, and I don't know why this proof got thrown in where it did, because this kind of doesn't go along with the properties of congruence. But just remember, keep it in your back pocket. We have those properties of congruence just in case we need them in future proofs. And this will probably be our last proof of the day. Angles 6 and 7 form a linear pair. Well, I don't know what a linear pair is. I just threw that away, right? I didn't think I would ever need it again. Don't do that. Everything that you learn this year, do not forget, because it's going to come back up over and over and over. Linear pairs. A linear pair are two angles that have a common side here that form a straight line. So angles 6 and 7 form a linear pair. Let's write down our given. Angle 6 and angle 7 form a linear pair. We'll call it an LP. The measure of angle 6 is 3x plus 32. The measure of angle 7 is 5x plus 12. Reason?
Okay, somebody tell me what you know about a linear pair. It equals 180. And you've got to be careful about your steps here. When you're dealing with proof, like I said, proofs are really picky and specific. That's actually 2 steps. What he just told me was 2 steps. If you look back, and you don't have to, I promise you it's there. If you look back in your notes, it nowhere does it say a linear pair adds up to 180. It says linear pairs are supplementary. Remember that? That would be our next step. Angle 6 and angle 7 are supplementary. And I want you to go through both of these steps. Because, and if you don't remember what it's called, that's fine. You know what I'm going to put for a reason? I'm going to come out here and say linear pairs are supplementary. That's why. So therefore, since angle 6 and angle 7 form a linear pair, that means they're a supplementary. Why? Because linear pairs are supplementary. And step number 3, I know since they're supplementary, what does that mean about them? Like we said, add up to 180. So now my step number 3, I'm going to say the measure of angle 6 plus the measure of angle 7 equals 180 degrees. I'll give you a second to think about the reason why. Now why? Why does angle 6 and angle 7 add up to 180? What's the reasoning behind that? How do I go from step 2 to step 3? In step 2, all I knew was that angle 6 and 7 are supplementary. In step 3, I now know that the measure of angle 6 plus the measure of angle 7 is 180. How did I go from there to there? Isn't it all based on this word right here? What does it mean to be supplementary? That add up to 180. So anytime you find yourself asked or making a statement, trying to reason, and you tell me, well, that's what it means to be supplementary. Exactly. So that's what we're going to put. That's the definition of supplementary. Or you might be saying, well, that's what it means to bisect something, or that's what it means to be a linear pair, or that's what most of the time that's going to be a definition. Okay, now, we're trying to find x. It says justify each step. Really, they're not giving us a goal here. It just says find x. So what I'm going to do now, measure of angle 6, well, that's equal to this. Measure of angle 7, that's equal to this. You've already done these this year. You've just not had to justify each step. So the measure of angle 6 is 3x plus 32. Seems like a lot of unnecessary work. The measure of angle 7 is 5x plus 12, and I know that that adds up to 180. We substituted, guys. Substitution property of equality. Step 5. I'm going to say, let's see, we're going to subtract 32, we're going to subtract 12. Let's use our subtraction property of equality first. Subtraction property of equality. Subtract 32, subtract 12, I now have 3x plus 5x equals 136, I think. Now on this, combine like terms. You just tell me what you did. Combine like terms. Just tell me, justify. I don't care what you call it as long as you're telling me what you just did. To get from 3x plus 5x equals 136 to 8x equals 136, you combine like terms. Step 7. We're going to divide. Division property of equality, and somebody do that for me, please. See what you get. X is 17. Okay, last step, and I'm gonna cheat a little bit on this one. Step 8, because it says find the find the value of x, and it also says to find the measure of angle 6 and the measure of angle 7. Like I said, I'm going to skip some steps and kind of cheat a little bit. The measure of angle 6 is 3x plus 32. X is 17, so that's 51 and 32, which is 83 degrees. Measure of angle 7 was 5x plus 12. X is 17, that's 85 and 12, which is 97 degrees. In my reasoning there, I did substitute. I used the substitution property of equality, and I also went ahead and did some basic, you want to put PEMDAS, order of operations to actually simplify. You can put basic algebra, you put whatever you wanted to. You cleaned it up, okay? And that's what you got. You substitute in, you cleaned it up. Measure of angle 6 is 83, measure of angle 7 is 97. And you can even check that. If you add those two together, they are supplementary. They do form a linear pair. You've done these. You've been doing these all semester. You've just not had to justify your steps. Okay, now the only difference is we're justifying steps along with it.